Hello class, this is a video tutorial on applying index laws to the expansion of algebraic groups. But before we get into the index laws in groups, we're going to learn how to, review expansion of groups first. So let's go back to the distributive law of multiplication. Now, the name's not so important, although you can try and remember it if you like. It's more important to understand what it means. If we have, let's say, some group B plus C, and we have a letter in front of it, or a number in front of it. Remember, these can be numbers. A outside B plus C. This will equal A times B plus A times C. So that A multiplies to each one. So it'll become AB plus AC. If we have more groups, so let's take for example A outside B plus C minus D, the exact same thing happens. This letter or this number will multiply to each one individually. So it's going to become A times B plus A times C minus A times D. So this will become AB plus AC minus AD. And even if we had B, C, D, E, F, G, it just multiplies to each one individually. So if this were, for example, this last example for the distributive law, if we had A outside B plus C plus D plus E plus F and so on, it'll become, I'm not going to do this part, I'm going to go straight to the end. It's going to be AB, because it's A times B, plus AC plus AD plus AE plus AF and so on. So let's take this and use our example of, we'll do two examples. Example A, which is 5 outside 2y plus 3, and that's example A. Example B is 7 3y minus 4w. So this one will equal, expanding the group, 5 times 2y. So 5 times 2 is 10. Y. 5 times positive 3. 5 times 3 is 15. So that's our expanded group. Let's take this as our example. This will equal 7 times 3, which is 21y. So 7 times 3. 7 times negative 4. Well, 7 times 4 is 28. But 7 times negative 4 is negative 28. Letter, which is W. Let's stay as it is. Okay, so let's do one more example. We'll do two more examples for this. Example A, B, example C. Make this 3, 2W plus 5. this will equal 3 times 2 is 6. W. 3 times 5 is 15. And we'll go straight to a really hard one now. That way we're not too confused. We'll take example D. 5 outside 3a plus b minus 7c. Okay. No problem. 5 times 3 is 15. Well, there's an a here, so it has to remain. 5 times b, positive b, so it's a plus, so plus 5b. 5 times 7 is 35c, but it's a negative 7, so it's going to be a negative 35. Now let's do a few examples. So these are just numeric multipliers, so 5, 7, 3, and 5. What happens if we have it as a letter? So we're going to new set of examples. Example A again. Let's take 3w outside 2y plus 4z as our example. Close the bracket. Well, what happens to this one? Well, I hope you're not too phased or too shocked by what's going to happen. So it's going to be the numbers first. So 3 times 2 is 6. W times y, it's just wy. And then 3 times 4 is 12. Then w times z is wz. Example B. Now here's what we're going to do. This is the index laws now. We're going to apply the index laws to our expansion of groups, because the index laws isn't self-contained into one topic. It applies to all of algebra, which we'll be encountering forever from now on, really. So 2 times 3 is 6. And now if we remember from index laws, if we're multiplying the same base, so a times a, we add the indices. Well, this a here has an indice of 1. I'll write that in pencil just so we can see. Has an index of 1. And so does this one that has an index of 1. And they're going to be adding. So it's going to become a squared. That's just for those with the same letter or the same number. Oops, don't worry about that. And we're not done. 2 times negative 4. Well, 2 times 4 is 8. 2 times 4 is 8. So 2 times negative 4 is negative 8. A times b. Well, that's just a b. Okay, so now let's take a look. We'll do another example. A slightly more complicated one. A, B, example C. Example C. We'll make it 4m squared, open bracket, m cubed plus 2m5. So, well, this will become numbers with, well, number 4 times, well, this has a 1 that we don't speak of, but there's a 1 there. So 4 times 1 is just 4. M times m squared times m cubed. Well, we know, or I hope you remember, to add the indices for this. So it's going to become m5. 4 times 2, That's 8, and it's a positive 2, so it become positive 8. M times m, well, same base, so squared times to the 5th, so that's going to add the indices, so that's going to be 2 plus 5 is 7. And now here we don't collect like terms because these only letters with the same index are like terms. So m to the 5 and m to the 7 cannot add. Okay, I'll show you an example of where they can. Let's take this for example. See, let's say we have 3k cubed plus 2k outside k squared plus, we'll make that 3k squared, make this one 4k squared. Now this looks a little complicated, but all we do first is expand the group first. So since we're going to be doing this group first, we're going to leave this one on its own. So it's going to copy the exact same thing. I haven't touched it. So positive 2k times 4. So 2 times 4, that's a positive. So it's going to be 8. 2 times 4 is 8. K times k squared. Well, these indices will add, so that's a 1, and that's a 2. So it's going to be k to the power of 3. Positive, plus and plus. 2 times 3 is a 6. K times k is k squared. And now earlier I told you how these cannot add because the indices are different. Because it's 5 and that's 7. So m to the 5 and m to the 7 are different terms, so they cannot add. Now if you take a look here, k cubed and k cubed, or k to the 3 and k to the 3, these can add. These are like terms. So we're going to add the 3 and the 8 to give us 3 plus 8 is 11k, and that's still the same, cubed. Remember, the only time they can increase is if they're multiplying. And what we do with this one, well, since this is not interacting with anything else, this stays as it is, 6k squared. So these are just a few examples. So now let's move on to what happens if we have negative multipliers. So here's a new set of examples. Let's take a look at negative 2y plus 3. That's the center. We'll take another example, example A, example B. We'll do 3 for this one. Negative 5a plus 2. And let's take the example C of negative 3a outside 5a squared plus 2ab. That one looks very complicated, but we can do it. Let's take a look at this. Well, it's the exact same thing, but this time there's a negative. So negative 2 times y. And remember, if there's a letter without a number in front of it, it's a 1. So negative 2 times y is negative 2y. Negative 2 times positive 3, negative 2 times positive 3, well, that's going to be negative 6. And now these are not like terms, so it stays as it is. Same thing. Negative 5 times a, well, that just becomes negative 5a. Negative 5 times 2, positive 2, it's positive 2. So negative times positive is negative 10. I'll take this as our last example. We have negative 3a times 5a squared. Let's break this down a little bit. Negative 3, we'll do the numbers first. Negative 3 times 5. 3 times 5 is 15. But negative 3 times positive 5 is negative. Negative times positive. This is a to the power of 1 times a to the power of 2. So they have the same base. They're going to add. And the same thing's going to happen with this. Negative 3 times positive 2. Well, negative 3 times positive 2 is negative 6. That's a times a, so that's a squared. And b has to remain as it is there. So now what happens if we do an example where there's negative? There's a lot of negatives in this one. Watch. Negative a squared 5a to the power of 2 minus 4ab. Let's take a look. A squared times a squared. So these indices are going to add a to the power of 4. Now remember how we said that if there's no number in front of a letter, we assume there's a 1. So there's a 1 here. 1 times 5 is 5. Negative 1 times positive 5 is negative 5. Here's where it gets really tricky. Negative 1 times negative 4. Negative times negative is a positive. 1 times 4 is 4. That's a 2. That's a 1. They're going to add. So it's going to be a cubed. It's going to be b. And one final one, just so that we get get all our examples going. A, B, C, D, E. Last example, we'll take this one. Get really complicated now. 7a 2a minus 3b minus 3a outside 3a plus 4b. So the first thing we're going to do is expand each group individually. So let's expand this group first. This is going to become 7 times 2 is 14. A times a is a squared. 7 times negative 3 is negative 21. A times b is a b. And we're done with this group. Let's move on to this group. So negative 3a times 3a. Well, negative 3 times 3, that is negative 9. A times a is a squared. Negative 3 times positive 4th, negative 3 times 4 is negative 3 times 4 is negative 12ab. We have like terms, 14a squared and 9a squared. So I'm going to write these two in the next line next to each other. So it's going to be, this stays as it is. I'm going to move this guy over here. So it's going to be minus 9a squared. I just rewrote it so that it's next to each other. This is going to be negative 21ab, and there's another ab. So I'm going to rewrite this and make it on this side. 21ab minus 12ab. I just did that so that they're right next to each other. 14 minus 9 is negative 23. Oops, my bad. 14 times 9 is 5a squared. Minus 21ab minus 12. So minus 21 minus 12. That becomes negative 33ab. And that's the end of the expansion.